Hello everyone. So welcome in the new video. In this video, I will cover fourth part of the interrupt with UART. I've already made one video on USART or UART. Basically, UART is a serial communication protocol where you can send or receive message serially through and from microcontroller. So basically, UART is a asynchronous communication. However, here USART is there, but the normal you can say full form of the UART is universal asynchronous receiver transmitter. So the asynchronized means that there is no synchronization between the transmitter and receiver. Now what is synchronization? So synchronization means receiver can understand that where to start and where to stop. So let us say transmitter is trying to send 1111 message. So 4 times 1 message is there. That definitely it's a binary form. So how receiver will understand that there are 4 ones, right? So how receiver can understand where to stop and where to start? So for that we should have a clock signal. So clock would be the reference. So at the rising or falling edge, the receiver can come to know that okay, this is the next bit. Now if clock is not there, then what? So that is what we call UART or asynchronous communication. So instead of clock we have some frame sequence. Like in UART we have start bit, stop bit, parity bit, and along with the frame sequence we also have fixed baud rate. So baud rate is a, you can say, a rate of interval, means both transmitter and receiver should agree on the same value, then and then you will have effective communication. Because now transmitter knows that the baud rate is 9600, so I have to send my message with this interval only. So each byte should have this much interval. And also we have frame sequence. So now receiver can easily understand the message, because receiver know that first time one means start bit, then 8 data bits are there, then one stop bit is there, right? So this is what we call USART or UART, and I have already made one video previously, so you can watch that video also. So this will be the circuit. Now I have already made one video, so what is new in this video? So in this video I will demonstrate you the concept of UART with interrupt. So let us say I have this circuit. Okay, I have one LED is connected with PA10 and I have one UART terminal is there. Now I want to blink this LED, or let us say this is normal operation, whatever operation you want to perform with the microcontroller. For this demo, just understand or just assume that this LED is your basic operation. The LED should continuously blink. Okay, and along with that, you have to have some logic which can continuously monitor the UART, and upon receiving of certain message, your microcontroller should display that message. Okay, so now let us do this with two different way. First I will show you with the polling, and then I will show you with the interrupt. So for that, this is the circuit. Okay, so let us first enable the crystal. So we have to connect crystal, then let us use UART, enable this. Now as you can see, I have connected UART with PB6, PB7. So your multiplex pins are there. So by default it is there in PA9, PA10, but we can change this from the PA9, PA10 to PB6, PB7. So you can see PB6 is TX and PB7 is RX. So now we have the UART configured. I have one LED connected with the PA10. So I'm simply configuring PA10 as a GPIO output. Okay, and one last thing, since we want to use interrupt, so let us select this NVIC and enable this interrupt. You can see USART1 global interrupt is there. So just select this. Okay, and now generate the code. So I have not changed anything like baud rate or anything. I just configure the UART. I just select the GPIO and enable the interrupt. Okay, and now it will generate basic code for us. Meanwhile, you must understand the in circuit, or many videos I have used this UART. So now let us start with this. This is UART integer interrupt, right? So this is our code, I guess, and here drivers are there. In driver, this STMHL driver is there, and here UART is there, right? Yes, this is the UART. So if you don't know anything about the function, you can simply go through this and you will have understanding of all the basic function. So to send the message, we have transmit function, right? To receive the message, we have receive function. So let us search. We will not going to, yes, this is transmit and receive, right? So this is the function transmit, and same way receive also having similar type of arguments. So first of all, as I told you or I explained you earlier, that I have some fixed task and LED blinking, right? So let us blink the LED first of all with while one loop. So it should continuously turn on and turn off, right? That's it. This is what our basic required operation, which should be executed continuously. And along with this, we have another requirement is to check the UART, and if our required number of bytes or bits received, it should display on the same UART that okay, we have received this. So with polling mode, what we can do, because we want continuously monitor the UART, so we have to write this in while one loop only, right? And let us change this from transmit to receive. Okay, and now first argument is our handler. So you can see this is the handler UART1. So you can simply type and UART1. Then this is the variable where the message will store. So for now, let us use one variable named RX buffer. So I'm just declaring this. It can store up to this 4 bytes only, right? Let us say for 5 bytes, means start with 0, and this is the variable where we want to save the message from the UART, right? And number of size, so I want to receive only 5 bytes, and this is the timeout, so you can use any value. Let us say I'm just writing 1000 over here, and now I want to send this same message on the UART. Okay, so here also same type of arguments are there, handler, then what message you want to send, and then how many bytes you want to send, and what is the timeout rate. So now let us debug this code first of all. Then we will release that this, we will generate hexadecimal file, we will upload this on our circuit and run it. Okay, now release this. And remember, what if you don't know anything about the function, just go through this HL driver src function, and here you will find all the different types of functions for specific modules. and you can use internet, you can understand the function, and you can use this function in your code, right? So it's very simple, so no need to remember whole thing. In this STMCubeIDE, we have this type of facility where you will have all the basic reference codes are there for each and every module. Now let us enable the hexadecimal generation. So simply select post build, select this convert hex file, click over here, and now again release the target, and you have to check this release part here. Hexadecimal file should be there, right? Till now we don't have, and now this is the hexadecimal file. So let us copy the path of the release folder, because the hex file is there in this folder only, latest hex file. So I'm just copying this, I'm opening the circuit, I'm uploading the, right, and this is what the hexadecimal file is. And now run this code, right? So now you can see we have something what we want to achieve. 1 minute. I have to also set the baud rate. It's at 115200, right? Now run this and let us type anything. 1 2 3 4 5, sorry, 1 2 3 4 5 6 7 8 9. Let us rerun this. Now LED is not blinking, it is in off condition, right? Now let us type some message. 1 minute, something is there. We have to check the code why it is all automatically blinking. This is UART receive, right? This is our UART1 is a handler. RX buffer is the variable where the message will receive, okay? And this is the how many bytes you want to receive, and this is simple timeout function. So just I'm changing this delay, release this, generate the target again, and now I'm running the code. Now you can see LED is still in off condition. Now I'm just typing one message, 1 2 3 4 5, and here you can see the message is there, and now LED will turn on, and again it will simply blink only one time. Again now microcontroller is in polling mode, because microcontroller is looking for a message on UART, and since we are not using any DMA or interrupt, so here microcontroller is in continuous waiting condition, which is called polling mode. Okay, now let us explore the interrupt part, how we can replace this and how we can use interrupt to you know reduce this overhead time, or you can say remove this waiting period. So for that we have another function called UART receive it. Okay, and this time I will simply write this function one time outside of the while loop. Here you can see only three arguments are there: interrupt handler, variable, and size. Okay, so this is what only one time we have to use this. Okay, now no need to do all this thing, but if you remember my previous video, then we should have one callback function. So whenever interrupt will generate, ultimately it will execute the callback function just after this interrupt serving, and after calling this callback function, again microcontroller will come to its original position. It will start execute the rest of the part of the code, right? So just I'm searching this callback, right? And here you can see, since we are doing this receive interrupt concept, we are just using this. So I have to use this HL RX callback function, and here is the function. So I will simply use this as it is in my code, and we have to declare this outside of the main function, right? Because this will only execute when interrupt will be there. Okay, so this is what the function. Now first thing is I have to check that whether the interrupt is coming from the my specific UART, because this is for the UART receive callback function. So we have to check that whether the interrupt is comes from the specific UART or not, right? So here I'm just checking. Okay, instance is equal to UART2, right? I'm using UART1, right? Sorry, so we have to use UART1. Okay, so if interrupt is come from the UART1, then execute this part. In this part, what we will do, we will simply print our received message, but along with this I will also add one more message. Data received. Okay, and this time I will simply do this typecasting with this message, and okay, message. And this is what the code is. So now what this function will do, sorry, I have to remove this part, this will generate error. Let us release this target. Okay, and now what this function will do, so now this function will allow this LED to blink continuously without any delay, because we are using this UART receive interrupt function. So once it will initialize, it will wait for the required number of bytes to be received on this variable, and this will wait in parallelly, means this will not we can say not exactly as a polling, but this is interrupt mechanism. So whenever this amount of byte will receive, interrupt will be generated, and automatically it will execute this callback function, and in callback function we are simply displaying this message. And when we don't have any message on the UART, it will continuously executing this function, these LEDs. Okay, so now let us rerun this code. You have to observe the LED. You can see this LED is continuously turning on and turning off without any further delay or without any exception. Now I'm just simply type one message 1 2 3 4 5, and you can see data received, and data is 1 2 3 4 5, right? Now again, after executing this, now our execution is here, so we have to enable this interrupt, and for that I'm just copying this function again over here. Now I'm generating again new hex file. This is, now I'm running the code. So here you can see LED is blinking. Now I'm typing message. This time I will type A B C D E, A B C D E, and you can see message is there, data received A B C D E. And now again you can see LED is continuously blinking. So this is how you can use this received it function. So instead of polling, now interrupt based communication is there. So it will allow processor to perform another task without waiting or without polling the required functionality. So this is what for today's video. If you like my work, then please like my YouTube video, subscribe my YouTube channel, share this with your friends. Till then, bye bye. Thank you.